Hello, and welcome back to Deep Space Intelligence. I'm Liam, and if this is your first time here, this channel is dedicated to exploring the universe's most compelling, most carefully researched questions. We dig into space science, anomalous phenomena, and the boundaries of what humanity currently understands. We take these subjects seriously, and we bring you the most accurate picture we can construct from verified sources, credible institutions, and the scientists who have devoted their careers to figuring out what's real. Today's episode is different from anything we've covered before, not because the subject is new, it isn't, but because something happened just days ago that has genuinely changed the landscape of what the public is allowed to know. On May 8, 2026, the United States Department of War launched a dedicated government website and began publishing what it described as never-before-seen files on unidentified anomalous phenomena. That's the modern term for what most of the world still calls UFOs, and these weren't summaries, weren't press releases, weren't carefully worded statements designed to say everything while revealing nothing. These were primary source documents, raw military incident reports, declassified FBI case files, NASA transcripts from the Apollo missions, infrared videos captured by military aircraft above the Persian Gulf, the western United States, the skies near Japan, 161 records in the first batch alone, representing decades of encounters the government has been collecting, analysing, and quietly filing away in classified vaults. The program behind this release has its own acronym, as Washington tends to prefer. It's called PURSUE, the Presidential Unsealing and Reporting System for UAP Encounters. It was launched at the direction of President Donald Trump, following a directive he issued in February of this year calling for the identification and public release of government documents related to alien and extraterrestrial life, unidentified aerial phenomena, and, to use the directive's own language, any and all other information connected to these highly complex but extremely interesting and important matters. The interagency effort pulling this release together spans an extraordinary range of institutions: the White House, the Office of the Director of National Intelligence, the Department of Energy, NASA, the Federal Bureau of Investigation, the All-Domain Anomaly Resolution Office housed within the Department of War, and additional components of the American intelligence community. That scope alone should tell you something. This isn't a single agency deciding to air its filing cabinets. This is a coordinated, whole-of-government decision to make public material that, until very recently, required security clearances to access. The question, of course, is what's actually in these files, and what does the scientific community make of what's been revealed? To understand why this moment feels so significant, you need to understand something about the long and frequently uncomfortable history of how the United States government has approached this subject. It's a history that stretches back more than 7 decades, involves a succession of secretive programs most people have never heard of, and carries within it a genuine tension between national security imperatives and the public's right to know what its institutions have observed in the skies above its own territory. The story begins, as these things so often do, in the turbulent years following the Second World War. The late 1940s were a time of extraordinary aeronautical development. The Americans, the Soviets, and their allies were all racing to apply the lessons of wartime aviation to new and ever more capable aircraft. Jet engines, experimental lifting bodies, high-altitude reconnaissance platforms, the earliest prototypes of what would eventually become stealth aircraft. The skies were, in a very real sense, a laboratory, and in that laboratory, military pilots, civilian observers, and radar operators across the country began seeing things they could not explain. In 1947, a private pilot named Kenneth Arnold reported seeing 9 bright crescent-shaped objects flying in formation near Mount Rainier in Washington state, at speeds he estimated exceeded 1,000 miles per hour. The objects, he said, moved with an unusual skipping motion, like a saucer if you skip it across water. That phrase lodged itself in the popular imagination and gave rise to the term flying saucer, even though Arnold had never described the object's shape with those words. In the same summer, a rancher named Mac Brazel discovered strange debris scattered across a large section of his property near Roswell, New Mexico. The material was unusual enough that local military authorities initially described it in a press release as a recovered flying disc. Within days, that statement was retracted and replaced by an explanation involving a conventional weather balloon. The Roswell incident would become the most analysed, most debated, most written about unexplained event in the entire canon of UFO research, and it appears in the files released this month. An internal FBI memo from the Bureau's Dallas field office, now declassified in fuller form with fewer redactions than previous releases, records that a major in the Air Force called to inform the office that an object purporting to be a flying disc had been recovered near Roswell. That single sentence, written in the bureaucratic measured language of mid-century federal correspondence, has been circulating in partial form for years. Now we have more of the surrounding context, and researchers are working through what the newly unredacted pages contain. The government's formal response to the wave of sightings that followed was a succession of investigative programs, each one more uncomfortable with its subject matter than the last. Project Sign began in 1948, tasked with assessing the nature of the objects being reported. Its initial findings, which leaned toward the possibility that some percentage of sightings represented craft of genuinely unknown origin, were reportedly suppressed by senior Air Force leadership. Project Grudge replaced it in 1949 with an institutional mandate that pushed harder toward explaining everything away. And then came Project Blue Book, the longest-running and most publicly visible of the official investigations, which operated from 1952 until 1969 and accumulated records on more than 12,000 individual cases. The final report from Project Blue Book, produced by a University of Colorado committee chaired by physicist Edward Condon and released in 1969, concluded that nothing in the accumulated evidence suggested that UFOs represented a scientific puzzle worth continued study. The Air Force used that conclusion to justify shutting down Blue Book entirely, and for roughly 40 years, the federal government maintained an official position that can be summarized in a single sentence: there is nothing here worth investigating. That position began to crack quietly in 2007. The Defense Intelligence Agency quietly established a program called the Advanced Aerospace Threat Identification Program, commonly known by its initials as AATIP. The program was funded at roughly $22 million over 5 years, operated out of the Pentagon, and was tasked with investigating reports of unidentified craft with capabilities that appeared to exceed known human technology. It was not publicly announced. It was not disclosed to most members of Congress. It ran without fanfare until its funding was cut in 2012, though investigative reporting later revealed that elements of the work continued under different organizational umbrellas within the Navy and the intelligence services. The existence of AATIP became public in December of 2017, when the New York Times published a detailed investigative piece that confirmed the program had existed, named its director, and included declassified footage captured by Navy pilots during training exercises. That footage is now among the most widely viewed and most debated material in the history of this subject. 3 separate videos, known informally by the names the military assigned their associated incidents, show objects that appear to perform maneuvers that challenge straightforward conventional explanations. The shapes are indistinct, captured through infrared targeting systems. But the behavior is what attracted attention. Apparent acceleration without any visible exhaust plume, rotation, what pilots described as hovering against strong winds and then departing at remarkable speed. The Pentagon confirmed the authenticity of all 3 videos. The institutional response shifted markedly after 2017. Congress began receiving classified briefings. Senators and representatives from both major parties expressed varying degrees of alarm and frustration. In 2020, the Department of Defense formally established the Unidentified Aerial Phenomena Task Force under the Office of Naval Intelligence, with a mandate to detect, analyze, and catalog UAPs that could potentially pose a national security threat. The following year, the office produced a preliminary assessment delivered to Congress that documented 144 incidents reported by military personnel between 2004 and 2021. Of those, the assessment was able to attribute only 1 to a known cause. The remaining 143 remained unexplained. In July of 2022, the Department of Defense established the All-Domain Anomaly Resolution Office, typically referred to as AARO. This was a significant institutional step. AARO was not merely a successor to the task force. It was a broader, more permanent, more scientifically oriented body with a mandate that extended beyond the atmosphere into space, underwater, and into what researchers call the transmedium domain, meaning phenomena observed moving between different physical environments. A ARO was required to report to Congress regularly, both in classified and unclassified form. It published a public-facing website. It established secure reporting mechanisms for military personnel and government contractors. And it began building what it described as a scientific and intelligence analysis capability intended to apply rigorous methodology to a subject that had, for decades, been either ignored or treated as an embarrassment. What AARO found over its first 2 years of operation is worth examining carefully, because it establishes the context through which the newly released files should be understood. The office accumulated hundreds of reports annually. Between May of 2023 and June of 2024 alone, it received 757 new cases. Of those cases, it was able to resolve 49 definitively, attributing them to known objects including various types of balloons, birds, and commercially operated drones. An additional 243 cases were recommended for closure after peer review, also resolved to conventional causes. But 444 cases lacked sufficient data to allow any analysis at all, and were archived for potential future review. 21 cases were determined to merit further analysis by AARO's scientific and technology partners. This is the framework that matters when you look at the newly released files. Most of what gets reported has a conventional explanation. A significant fraction cannot be analysed because the data simply isn't adequate, and a small but persistent residue of incidents resists explanation entirely, not because investigators have concluded they represent something extraordinary, but because the information available isn't sufficient to draw any conclusion at all. AARO itself has been consistent on this point. Its published reports state clearly and repeatedly that no empirical evidence has been found to confirm the existence of extraterrestrial technology. But the office is equally clear that absence of evidence is not the same as evidence of absence, particularly when the underlying data is so often incomplete. In March of 2024, AARO released what it called the Historical Record Report, Volume 1, a comprehensive review of all official American government investigations into UFOs and UAPs since 1945. The report covered Project Sign, Project Grudge, Project Blue Book, the Condon Study, AATIP, the UAP Task Force, and AARO's own work. It reviewed classified and unclassified archives, conducted approximately 30 interviews with current and former officials, and partnered with intelligence community and Department of Defense personnel responsible for classified program oversight. Its key finding, widely reported at the time, was that no empirical evidence had been found for extraterrestrial technology. But the report also acknowledged something that receives considerably less attention in most coverage of this topic. It confirmed for the first time that elements within the American government had seriously proposed creating a classified special access program to reverse engineer any extraterrestrial craft that came into government possession. That proposal, known internally as Kona Blue and submitted to the Department of Homeland Security, was rejected as being without merit. No extraterrestrial craft existed to reverse engineer, but the proposal had been made seriously at a senior level by people who genuinely believed such material might exist somewhere in the classified infrastructure of the national security state. Now here's something I always want to be clear about on this channel. We research these topics carefully, we cross-reference claims against scientific sources, and we try to give you the most accurate picture the evidence supports. But I'd encourage you to go to the original sources yourself, to read the AARO reports, to look at what NASA's independent study team found, to check the institutional positions against what individual scientists are actually saying. This subject is complicated enough that no single source should be your only reference. Form your own picture. That's always the right approach. The files released on May 8th span an enormous range of dates, subjects, and levels of detail. The initial tranche consists of 120 PDF documents, 28 videos, and 14 image files drawn from 4 primary sources: the Department of War, the FBI, NASA, and the State Department. The videos run for a combined total of approximately 41 minutes. The documents range from single-page incident reports submitted by individual military personnel to multi-page State Department cables from diplomatic missions in Papua New Guinea, Kazakhstan, Turkmenistan, Georgia, Mexico, and Tajikistan, detailing UAP incidents observed in those countries between 1985 and late 2025. The geographic distribution of these incidents is striking. The files released so far show a heavy concentration of recent reports near active military operations. The Middle East, specifically the areas around the Strait of Hormuz, Iraq, Syria and the Persian Gulf, accounts for a significant share of the contemporary reports. According to AARO analysts and researchers who reviewed the files, this clustering almost certainly reflects the operational reality that the American military deploys its most advanced sensor systems in precisely those regions. Better sensors, operating in contested and complex airspace where multiple nations and non-state actors are flying a wide range of aircraft and drones, will naturally generate more unusual observations. That's not an explanation that eliminates the genuinely anomalous cases, but it does provide important context for interpreting the pattern. Some of the most immediately striking material in the release comes from the files on Apollo mission incidents. In newly released NASA transcripts from 1969, astronaut Buzz Aldrin, speaking to government debriefers after the historic Apollo 11 mission, described seeing what he characterized as a possible laser in space. His precise words were that he had observed what appeared to be a fairly bright light source, which he and his crewmates tentatively described as a possible laser. During the same debriefing, Aldrin also mentioned seeing what he called little flashes inside the cabin, spaced a couple of minutes apart, while attempting to sleep aboard the spacecraft. Flashes of light experienced by astronauts inside darkened spacecraft cabins are a known phenomenon with a well-documented physiological explanation: cosmic ray particles passing through the fluid of the eye and triggering the visual cortex directly, producing the perception of light without any external light source. The astronauts themselves understood this possibility, but the brighter external light, the possible laser, is a different matter, and one the debriefers apparently found worth documenting. The Apollo 17 material is receiving particularly intense attention. That mission, which landed on the lunar surface in December of 1972 and remains the last crewed mission to reach the moon, generated incident reports that are, in some respects, more detailed and more unusual than those from other Apollo flights. On the first day of the mission, Command Module pilot Ronald Evans reported observing very bright particles or fragments drifting and tumbling near the spacecraft as it maneuvered. Lunar Module pilot Harrison Schmitt, the only professional geologist to have walked on the moon, described the phenomenon as looking like the 4th of July. Mission Commander Eugene Cernan, one of the most experienced astronauts of the Apollo era, reported on the second day of the mission that he was having difficulty sleeping because of streaks of intense light. He described the light as not being an optical illusion, compared its intensity to a train headlight, and characterized it as, in his own word, imposing. The crew attempted to explain their own observations. They suggested the particles Evans and Schmitt saw might have been ice, or paint fragments, dislodging from a separated component of the Saturn V rocket's upper stage. Cernan described his judgment of that explanation as, in his own words, a wild guess. Mission controllers in Houston apparently heard all of this in real time and said nothing publicly about it for more than half a century. The photograph from the Apollo 17 mission that has attracted the most scientific scrutiny, since the release is a still image taken in December of 1972, showing 3 distinct dots arranged in a roughly triangular formation in the lower right quadrant of the lunar sky. The image has been available in various forms over the decades, as NASA has always maintained a policy of publishing its mission photographs. But what is genuinely new is the attached preliminary analysis from the Department of War, which states that there is no consensus about the nature of the anomaly, and that a new review of the image suggests the feature is potentially the result of a physical object in the scene. That formal assessment, stating that no consensus exists and that the objects may be physical, is different in kind from anything the government has said about this image previously. AARO has formally opened a case to investigate the Apollo 17 photograph. The analysis is ongoing. Harvard astrophysicist Avi Loeb, who leads the Galileo Project, a scientific research initiative dedicated to the systematic search for extraterrestrial technological objects, reviewed the first batch of released files with his research team within hours of the publication. His assessment was characteristically measured. After reviewing all 161 records, the team concluded that none of the objects in the release is sufficiently extraordinary to require an exotic origin. Most of the images, Loeb noted, could be explained as either reflections in camera optics or human-made objects. The Apollo mission images, he said, could reflect asteroid impacts on the lunar surface, a natural phenomenon, noting that Artemis II astronauts reported observing 6 similar flashes while flying near the moon just weeks before the files were released. But Loeb was also clear about what he sees as the significance of the release, independent of whether any individual file contains proof of something extraordinary. The opening of this subject to public and scientific discourse, he said, is itself important. The way that the subject was dismissed in the past, either within the scientific community or publicly, he argued, is no longer appropriate. This is a serious matter that needs attention. In his written analysis published on Medium immediately after the release, Loeb noted that the government's state-of-the-art sensors, deployed across decades of monitoring the sky and oceans, may have captured rare anomalies that have so far escaped the attention of civilian scientists. He described it as a civil duty for scientists to help the government analyze this data. He was also explicit about his expectations for what comes next. The best, he wrote, is yet to come. Higher quality data, he predicted, will require more time working through the layers of government bureaucracy before it can be cleared for public release. The Galileo project itself represents a genuinely novel approach to this problem. Rather than waiting for government disclosure, Loeb and his team have built their own observatories equipped with multiple simultaneous sensing modalities, optical cameras, infrared detectors, radio receivers, and audio sensors, designed to detect, track, and characterize any unusual aerial objects. The project currently operates 3 observatories, uses artificial intelligence to process and classify the data they collect, and is developing triangulation methods to determine the precise distance and velocity of any detected objects. Loeb has been explicit that his goal is to determine whether any observed objects lie outside the performance envelope of known human-made technologies. If the distance and velocity of an object can be measured with enough precision, and if those measurements reveal performance that no known aircraft, drone, or natural phenomenon can replicate, then the scientific case for something genuinely anomalous becomes substantially stronger. The reaction from the broader scientific community to the Pursue release has been divided in instructive ways. Those who study this subject professionally, a community that has grown considerably since the institutional shift of 2017, have largely welcomed the release as a meaningful step toward making serious research possible. The raw data in these files, however incomplete and often frustratingly low in resolution, represents a foundation that can be cross-referenced, analyzed with modern computational tools, and compared against other data sets in ways that were not possible when the same material sat in classified archives. Skeptics, including some who have followed this subject closely from a debunking perspective, have pointed out real and legitimate limitations in what the files contain. Many of the videos consist of grainy infrared footage in which the shape of the observed object is determined as much by the technical characteristics of the sensor as by the object itself. Infrared sensors, particularly in their older generations, are subject to a known artifact called a bloom effect, in which a bright heat source directly in the center of the frame produces a distinctive halo or flare that can create the visual impression of an unusual shape, when the actual shape of the object may be quite ordinary. Analysts who examined some of the newly released footage pointed to specific examples where what appears to be an unusually shaped object is almost certainly a conventional aircraft, captured at the precise angle and distance where the bloom effect distorts the apparent shape. The website accompanying the Pursue release carries a disclaimer that makes this ambiguity official government policy. The descriptive and estimative language in the military memos, the site states, reflect the subjective interpretation of the person who wrote the report and should not be interpreted as a conclusive indication of what actually happened. That's an important caveat. Every incident report in these files is, at its foundation, one person's account of what they observed, filtered through whatever sensor system they were operating, shaped by whatever training and experience they brought to the moment, and written down afterward in the bureaucratic language of military reporting. The raw report is evidence that something unusual was observed, or perceived to be observed. It is not by itself evidence of what that something actually was. This distinction matters because it sits at the heart of the disagreement between those who interpret these files as confirmation that something genuinely unknown is operating in American airspace, and those who read the same files as a large collection of unexplained but probably explicable observations. Both positions can be held in good faith by people who have read the same documents. What the files reveal with somewhat more certainty is a pattern of geographic concentration. The bulk of the contemporary reports, those from the last decade, cluster heavily around active military operations and military installations. The Strait of Hormuz appears in multiple incident reports from different years and different units. Iraq and Syria, where American forces maintained substantial presences during operations against the Islamic State, account for a significant share of the recent Middle Eastern reports. One document describes a 2024 incident in Iraq where a mysterious craft was observed crossing the surveillance systems of an American aircraft at high speed, while that crew was engaged in an unrelated strike operation. Another describes multiple glares or light sources of unknown origin observed over Syria during the same year. There are also reports from American personnel stationed in Greece and the United Arab Emirates. The concentration of sightings near military assets is not simply a curiosity. It raises an issue that the national security community has been wrestling with explicitly since at least 2017, which is the question of adversarial surveillance. The United States military operates some of the world's most sophisticated equipment in some of the world's most strategically sensitive locations. If an adversarial nation, Russia, China, Iran, or any other actor with the technical capability to develop advanced unmanned platforms were deploying surveillance or probing systems near American forces, those systems might appear to pilots and sensor operators as exactly the kind of unusual, high-performance, apparently technologically advanced objects that appear throughout these files. That possibility is treated by AARO and by the broader national security apparatus as genuinely urgent. It is, in the assessment of many analysts, a more immediately practical concern than any hypothesis involving non-human origin. The FBI files within the Pursue release are among the most varied in character. They range from recently declassified versions of long-discussed historical documents, like the Roswell memo with fewer redactions, to very recent incident reports submitted by government intelligence personnel in the field. One account from 2025 describes a senior intelligence officer relaying to the FBI a report from American government personnel who had gone searching for orb-type phenomena in an area where such objects had been previously documented. According to the official description of the report, after the team searched the area using a helicopter, they found what was described as a super-hot orb hovering over the ground. The orb, the report states, travelled 20 miles at a speed too fast for the helicopter to match in pursuit. That incident remains unresolved in the current release. No additional context, no analysis conclusion, no identification is provided. The orb phenomenon appears repeatedly throughout both the historical and contemporary sections of the released files. Orb-type objects, small spherical or near-spherical light-emitting phenomena, observed in a wide variety of contexts, have been one of the most commonly reported categories of UAP in AARO's ongoing case intake. They appear in military reports from multiple theatres of operation. They appear in the FBI accounts. They appear in the records of sightings near sensitive facilities. What they are, whether they represent a single category of object or several distinct phenomena that happen to produce similar visual signatures, is one of the genuinely open questions that AARO has identified as deserving further scientific attention. There are older files in this release that carry a very different quality. A collection of documents from the 1950s and 1960s describes Cold War-era encounters, many of them in the airspace over or near the divided Germany of that period and in regions bordering Soviet-controlled territory. A report from the United States Embassy in Tajikistan, dated 1994, describes the experience of a commercial airline pilot and crew who reported observing a strange object at 41,000 feet. The State Department cables in general, spanning from 1985 to late 2025, and originating from diplomatic missions in Kazakhstan, Turkmenistan, Georgia, Papua New Guinea and Mexico, demonstrate that whatever is being reported in American airspace is also being observed internationally, through channels the American diplomatic establishment considered worthy of formal reporting back to Washington. There is a memo in the FBI files that dates to 1966 and describes a report of what witnesses described as small beings emerging from a saucer-shaped craft. Composite sketches were attached to that report. Whether those sketches are among the elements now made public with fewer redactions is still being determined by researchers working through the documents. Historical accounts of this kind present obvious analytical challenges. They are products of a specific cultural moment, filtered through the perceptual frameworks and reporting conventions of their time, and they describe events for which no physical evidence has been recovered or verified. But they are in the files. They were considered worth reporting by trained observers and law enforcement professionals, and they are now available for the public to read and evaluate. The question of what, precisely, the American public and the international scientific community are meant to do with all of this material is one that the government has addressed in a way that is either refreshingly honest or somewhat evasive, depending on your perspective. The Department of War stated explicitly that the purpose of the release is to let Americans make up their own minds. NASA Administrator Jared Isaacman, commenting on the release, described it as consistent with NASA's mission to follow the data and share what is learned, acknowledging that much remains to be discovered. AARO continues to maintain its position that no confirmed evidence of extraterrestrial technology has been found, while simultaneously acknowledging that hundreds of cases in its database remain unresolved. This is, in essence, the honest position the evidence supports. There are unexplained phenomena being observed by credible observers using sophisticated sensor systems. The nature of those phenomena is not currently known in a significant minority of cases. Most cases, when there is adequate data to analyze them, resolve to conventional explanations. The data available for most cases is not adequate to reach any conclusion at all. It is worth understanding, for context, why the data tends to be inadequate so often. Military sensor systems are designed for specific operational purposes. An infrared targeting pod on a fighter aircraft is optimized to identify heat sources associated with weapons, vehicles, and aircraft. It is not calibrated for scientific measurement of unusual phenomena. It captures what falls within its field of view during a brief encounter, without the controlled conditions, calibrated instruments, and multi-sensor corroboration that a scientist would need to say something definitive about what was observed. Pilots are, necessarily, focused on their primary mission. By the time an unusual observation is registered, has been communicated to other crew members, and has been formally reported through military channels. The encounter is often already over, and the opportunity for additional data collection has passed. AARO recognized this limitation and began developing a dedicated sensor system specifically for UAP detection. The program, known as Gremlin, contains multiple simultaneous sensing modalities and is designed to detect, track, and characterize unusual aerial objects with the kind of data quality that scientific analysis requires. A prototype was tested in March of 2024, and AARO was planning a 90-day monitoring deployment at a site of national security significance. The data from that deployment, and whatever subsequent deployments may have occurred, presumably forms part of the growing classified database that has not yet worked its way through the government review process into public release. The involvement of artificial intelligence in the analysis of UAP data is another thread that runs through the current moment in ways that would have been impossible a decade ago. AARO has acknowledged using advanced modeling techniques in its case analysis. The Galileo project is training machine learning systems on labeled imagery to improve detection and classification. Private technology companies in Silicon Valley, according to reporting from researchers who have been following the Pursue release closely, are already treating the newly released sensor data as a training dataset for machine learning models, aimed at identifying commonalities in patterns of behavior across cases from different years and geographic locations. Seth Shostak, a senior astronomer at the SETI Institute, which has been searching for radio signals from intelligent extraterrestrial sources for more than 6 decades, offered an assessment consistent with his long-standing position on this subject. Most UAP sightings, he noted, resolve to prosaic causes when examined carefully. But he acknowledged that the small fraction of genuinely unresolved cases merits serious scientific attention, and that the institutional shift toward treating this as a legitimate subject of inquiry is healthy for science, even if it produces no dramatic revelations in the near term. The SETI community's relationship with the UAP subject has historically been complicated. For most of its history, the search for extraterrestrial intelligence has focused on detecting electromagnetic signals from distant star systems, on the grounds that any civilization capable of crossing interstellar distances would presumably also be capable of broadcasting detectable radio or optical signals. The possibility of physical visitation, either by automated probes or crewed vehicles, was largely considered outside the scope of serious scientific inquiry, partly because the physics of interstellar travel are genuinely daunting, and partly because the UFO phenomenon had accumulated such a heavy cultural association with sensationalism that most scientists preferred to stay at a safe distance. That distance has been closing. In 2017, astronomers detected an unusual object passing through the solar system on a trajectory that had brought it from interstellar space. The object, designated 1I/Oumuamua, had a shape that appeared inconsistent with any known class of natural object, a highly elongated cigar or pancake form, and exhibited a non-gravitational acceleration that could not be explained by the pressure of sunlight alone. Avi Loeb became one of the most prominent voices arguing that Oumuamua's anomalies were worth taking seriously as potential evidence of extraterrestrial technological origin. The majority of the astronomical community favoured natural explanations, most prominently the hypothesis that Oumuamua was an unusual type of comet releasing gases that could account for its unexpected acceleration. No consensus was ever reached. In August of 2019, a second interstellar object was detected, this one designated 2I/Borisov. Unlike Oumuamua, Borisov behaved like a conventional comet and generated no scientific controversy about its nature. And then, in July of 2025, a third interstellar object was detected by the Atlas Survey Telescope. Designated 3I/Atlas, this object has attracted enormous scientific attention, in part because it exhibits a set of anomalies that Loeb and other researchers have found deeply interesting, including unusual jet structures, anomalously high levels of deuterium, and non-gravitational acceleration patterns that have generated extensive discussion in the scientific literature. The 3I/Atlas story is ongoing and represents a separate but genuinely fascinating thread that intersects with the broader question of what might be moving through the solar system and why. The intersection of the interstellar object story with the UAP file story is not trivial. Both involve the question of whether something of non-terrestrial origin might be observable in the near-Earth environment. Both involve phenomena where the available data is insufficient to reach definitive conclusions. And both have, in the last several years, moved from the margins of scientific discourse into the mainstream. What connects them is a question that Loeb has put with characteristic directness. If there are other technological civilizations in the universe, and if the universe is old enough that some of them are likely far more advanced than we are, then the solar system is not a place they have necessarily left alone. The nearest star system, Alpha Centauri, is approximately 4¼ light-years from Earth. A probe travelling at 1% of the speed of light, a velocity that is challenging but not obviously impossible for a sufficiently advanced civilization, would cover that distance in roughly 425 years. The universe is approximately 13.8 billion years old. The Earth has been here for 4.5 billion years. If even a small fraction of the stars in the Milky Way host civilizations substantially older than ours, the question of whether such civilizations might have sent probes to explore nearby stellar systems, including ours, is not obviously absurd. This is not to say that the UAP files released this month contain evidence of such probes. They do not, or at least they contain nothing that approaches the standard of evidence that would be required to make that claim with any scientific confidence. But it is the frame within which the more open-minded members of the scientific community are beginning to approach the subject. The files also illuminate something about institutional culture within the American military and intelligence communities that is, in its own way, as interesting as any individual incident report. For decades, pilots and military personnel who encountered unusual phenomena in the course of their duties faced a genuine professional disincentive to report those encounters. The unofficial culture around UFOs within the services was dismissive at best and contemptuous at worst. Reporting an encounter that might be attributed to the witness's imagination or incompetence was a potential career risk. The result, according to AARO analysts, was systematic underreporting. An unknown number of genuine encounters that would have been worth investigating were never formally documented because the individuals who experienced them calculated that filing a report would do them more harm than good. This cultural reality is part of why AARO's mandate explicitly includes the destigmatization of UAP reporting. The office has worked to establish secure reporting channels to ensure that personnel who file reports are protected from negative career consequences, and to communicate that the collection of this data is a legitimate and valued contribution to national security. The effect has been a significant increase in reporting volume since the establishment of formal mechanisms. Whether that increase reflects a genuine increase in unusual encounters, a reduction in the stigma-driven suppression of reports, or simply greater awareness of available reporting channels is itself difficult to determine. There is a moment in the history of this subject that deserves particular attention because it sits at the intersection of institutional culture, scientific skepticism, and genuine mystery. In 2023, a former intelligence officer named David Grush testified before the United States Congress. Grush, who had served as the National Reconnaissance Office's representative to AARO, claimed that the American government had in its possession physical materials recovered from what he described as non-human craft. He claimed that a secret reverse engineering program had been operating for decades, largely through contractor arrangements designed to keep the work outside normal congressional oversight. He acknowledged under questioning that he did not have direct first-hand access to the materials he described. His knowledge, he said, came from classified second-hand reports and interviews with other officials who claimed direct knowledge. The claims Grush made were serious enough that Congress took them seriously. Hearings were held. Additional classified briefings were provided. The AARO Historical Record Report addressed the Grush allegations explicitly, concluding that it had found no empirical evidence for the existence of non-human craft or materials in government possession. But the report also acknowledged that it could not rule out the existence of programs so deeply buried in the Special Access Program infrastructure that even AARO's extensive review had not been able to locate them. That is not a definitive conclusion either way. It is an honest acknowledgement of the limits of what any investigation can establish when the systems it is investigating are specifically designed to resist scrutiny. The new files do not resolve the Grush question. They do not contain a smoking gun that confirms secret programs or crashed craft. But they also do not provide the kind of comprehensive, verified, alternative explanation that would decisively close the case. The government's own position, consistently stated, is that it has found no evidence of non-human technology. What it has found, what fills these 161 records, and whatever additional tranches the Pursue program will release in the weeks and months ahead, is a substantial body of documented encounters that, in the government's own assessment, remain unresolved. The State Department files are among the least publicized elements of the initial release, but carry their own weight. Diplomatic cables from American embassies in 5 countries spanning 4 decades describe incidents reported by commercial pilots, local authorities, and American diplomatic personnel. These are not anonymous internet posts. They are official communications sent through secure diplomatic channels from trained American Foreign Service officers to the State Department in Washington. They were considered important enough to document, to transmit securely, and to retain in classified archives for decades. The fact that they appear in a release focused on unresolved UAP incidents suggests they were never satisfactorily explained through the normal course of diplomatic or intelligence analysis. The cable from the American embassy in Tajikistan in 1994 describes a commercial air cruise encounter with a strange object at 41,000 feet. Commercial aircraft at cruise altitude are subject to extensive radar monitoring, and any encounter with an unidentified object at that altitude represents a potential aviation safety issue, as well as whatever other implications the sighting might carry. That the incident was documented by the American diplomatic mission, rather than by local aviation authorities, and was transmitted to Washington, reflects the judgment of the embassy staff that this was a matter of significance. What became of it in Washington, whether it was analysed, whether it was correlated against other reports from the same region and period, is not apparent from the released documents. These are the questions that researchers, scientists and journalists are now working through with access to material that was, until 3 days ago, classified. The Pursue website carries a rolling disclosure model, with new tranches of documents promised every few weeks, as additional material is reviewed and cleared for public release. The 46 videos specifically requested by Congresswoman Anna Paulina Luna, which are not included in the initial batch, are among the items expected in future releases. Loeb, in his post-release analysis, expressed hope that higher quality sensor data, the kind of imagery that reveals enough about an object's distance, velocity and behavior to draw scientifically meaningful conclusions, will emerge as the review process continues. The physics of what would be required to confirm something truly anomalous in the UAP data is worth understanding precisely because it sets the standard that the current evidence does not yet meet. To establish that an observed object is performing beyond the capabilities of any known human-made technology, you need to know its distance from the observer, its velocity, and its acceleration. With those 3 quantities, you can calculate whether the object's behavior is consistent with known aerodynamics and propulsion physics, or whether it violates them. most of the footage in the current release was captured by sensors that were not designed to collect the data needed for those calculations. The objects appear in frame without reference points that would allow precise distance estimation. Their speed is inferred from apparent motion across a sensor field of view without the triangulation necessary to convert apparent angular motion into true velocity. This is not a criticism of the people who filed these reports or operated these sensors. It is a description of the fundamental limitations of data collected by systems not designed for this purpose. The Gremlin sensor suite AARO was developing was specifically intended to address exactly this gap. Whether Gremlin has produced usable data, and whether that data will eventually make its way into the public record through Pursue or some other mechanism, is one of the more significant open questions in the current landscape. What is already clear, even from the initial release, is that this moment represents a genuine shift in the official American government's posture toward a subject that it spent decades either actively suppressing or treating with institutional contempt. The question of whether that shift will ultimately produce answers, whether the accumulated evidence will eventually yield to analysis, whether the genuinely unresolved cases will find resolution through better data collection, more sophisticated analysis, or future disclosures, remains entirely open. The scientific community's response to this moment is itself worth watching as closely as the files themselves. Loeb's framing is instructive. The importance of the release is psychological as much as evidentiary. It moves the subject from the margins of acceptable inquiry into the mainstream of legitimate scientific discourse. That normalization has consequences. It means more scientists will feel comfortable directing their attention and their analytical tools toward this data. It means journals will be more willing to publish research on this subject without the reflexive dismissal that has characterized much editorial decision-making in this area for decades. It means the resources needed for systematic, scientifically rigorous observation, the kind the Galileo project is attempting to build from the ground up, become easier to justify and to fund. Whether that matters depends entirely on whether there is in fact something here worth finding. The honest answer, based on everything currently available, is that we do not know. The government does not know. The scientists most actively engaged with this question do not know. What they do know is that there are observations they cannot currently explain, that the institutional infrastructure for investigating those observations is more developed now than it has been at any previous point in history, and that the public now has access to a substantial portion of the raw material from which any eventual understanding will have to be built. The files published at the Pursue website on May 8, 2026 are the beginning of something, not the end of it. The Department of War has stated explicitly that new documents will continue to be released on a rolling basis as material is discovered and cleared for publication. What those future releases contain, whether they will include the higher resolution sensor data and more detailed incident analyses that researchers are hoping for, will determine whether this historic moment of transparency becomes a genuine contribution to scientific understanding or remains, as so many previous disclosures have remained, suggestive but inconclusive. There is one more dimension to all of this that has received relatively little attention in the initial wave of reporting, but which deserves careful consideration. The release of these files is happening against a broader backdrop of scientific discovery and technological change that gives the UAP question a different resonance than it would have had even a decade ago. The number of confirmed exoplanets, worlds orbiting stars beyond our Sun, has now exceeded 5,500. Among those worlds, a growing number have been identified as potentially habitable, meaning they orbit within the zone around their star where liquid water could exist on their surfaces. The James Webb Space Telescope has been observing the atmospheres of some of these worlds, searching for chemical signatures that might indicate biological processes. No confirmed biosignatures have been found yet, but the instrumentation is now powerful enough that if those signatures exist in detectable concentrations, we are capable of finding them. The Fermi paradox, the famous observation by physicist Enrico Fermi that if intelligent life is common in the universe, the galaxy should already be full of evidence of it that we have apparently not detected, has taken on a new character in the context of these developments. We are, for the first time in history, acquiring the ability to look for life beyond Earth in a systematic and scientifically rigorous way. We are doing so at the same moment that the government is releasing documents acknowledging that something is being observed in Earth's skies and oceans that it cannot currently identify or explain. That juxtaposition does not constitute evidence of anything specific, but it does suggest that the question of what, if anything, these unresolved observations represent is worth approaching with genuine scientific seriousness, not with the credulity that accepts extraordinary claims on the basis of extraordinary desires, not with the reflexive dismissal that insists on conventional explanations before examining the evidence, but with the honest, open, evidence-guided inquiry that is the only reliable method for separating what is real from what merely appears to be. The files are open now. The question of what they reveal is one that researchers, scientists, and informed members of the public will be working through for years, and the additional releases that the Pursue program has committed to will add layers of complexity and perhaps genuine clarity to a picture that is currently, despite the dramatic scale of this disclosure, still very much incomplete. When you look at the contents of these files without the scaffolding of preconception, without the expectation that they must contain either conclusive proof of extraterrestrial visitors or complete vindication of every conventional explanation, what you find is something genuinely interesting in its own right. You find the accumulated record of what trained military and civilian observers have reported seeing over the better part of a century. You find the institutional responses of a large and complex government as it tried, inconsistently and often uncomfortably, to decide what to do with that record. And you find the beginnings of what looks for the first time like a serious, well-resourced, scientifically informed effort to find out what those observations actually mean. That effort is now, officially, a matter of public record, and the data on which it rests is now available to anyone with an internet connection and the patience to read through 161 documents in the first release alone, with more on the way. The scientific framework for understanding what it would mean for any of these observations to be genuinely anomalous requires a brief but important digression into what we know about physics and propulsion. The objects described in military incident reports as performing unusual maneuvers, objects that appear to accelerate rapidly without visible exhaust, to make sharp turns at high speed, to hover without any obvious thrust mechanism, would, if those observations are accurate, be violating several well-established principles of physics as we currently understand them. The problem of high-G maneuvering, for instance, is not merely a question of structural materials or engineering. Any mass, whether a conventional aircraft or a theoretically advanced vehicle, is subject to the same inertial forces. A hard turn at the velocities described in some of these reports would subject any human occupant or any electronic system sensitive to acceleration to forces that would exceed the tolerance of any known material or component. The absence of any observed exhaust plume during rapid acceleration, if confirmed, would represent an equally significant departure from known propulsion physics. Conventional rockets and jet engines produce thrust through the reaction of exhaust gases. Electromagnetic propulsion systems capable of the accelerations described would require energy densities that have no current technological equivalent. This does not mean the observations are impossible. It means that if they are accurate and complete, they imply something about physics that we do not currently understand. That is either an extremely exciting scientific possibility or a reminder that observers, even trained ones operating sophisticated equipment, can misinterpret what they are seeing under conditions of stress, incomplete information, and unfamiliar atmospheric or optical effects. Both possibilities deserve to be taken seriously. The question of atmospheric optics alone represents a significant source of potential misidentification that is often underappreciated by people not familiar with the relevant science. The atmosphere is not a uniform, neutral medium through which light travels without distortion. Temperature inversions, humidity gradients, aerosol layers, and other atmospheric structures can bend light in ways that create convincing visual illusions of objects that are not where they appear to be, or that appear to be moving when they are stationary, or that appear to be a single cohesive object when they are reflections or refractions of multiple unrelated light sources. Pilots flying at altitude through complex atmospheric conditions can experience perceptual environments quite different from what a ground-based observer would see in the same moment. AARO's published reports acknowledge all of this. The office has explicitly noted that Starlink satellite launches have been correlated with reported UAP sightings by both military and civilian pilots who observed cascades of illuminated satellites passing overhead without recognizing what they were looking at. Balloons, both commercial and the high-altitude reconnaissance varieties operated by various government agencies, have been identified as the explanation for a significant fraction of resolved cases. Birds, particularly flocks of birds visible through infrared sensors at night, have produced UAP reports from credible observers. Sensor artifacts, calibration errors, cosmic ray hits on imaging detectors, and software glitches in data processing pipelines have all been identified as contributors to the pool of unexplained observations. What makes the residual genuinely interesting is that these explanations have been applied, thoroughly and in good faith, and a significant number of cases remain after the conventional explanations have been exhausted. The honest answer to why those cases remain unresolved is not necessarily that they are extraordinary. The honest answer is that the available data simply does not allow any determination to be made. The object in the infrared video was too far away, the encounter too brief, the sensor field of view too limited to establish the information needed to reach a conclusion. That is frustrating, but it is the truth of the current evidentiary situation. The question of what happens next in the pursue process is worth thinking through carefully. The government has committed to additional releases every few weeks as material is reviewed and cleared. That process itself is revealing. The fact that some material requires extensive review before release, that redactions remain in the current batch, that some of the most specifically requested items are not yet available, tells you something about what the government is balancing. There are legitimate reasons why certain sensor data and certain incident specifics might be withheld for national security reasons entirely unrelated to anything exotic. The capabilities of American surveillance satellites, the resolution of military targeting systems, the specific operating parameters of classified reconnaissance platforms, these are all things the government has compelling reasons to protect, regardless of what the sensors captured. The difficulty, of course, is that the same rationale for classification that protects legitimate national security interests also provides cover for withholding anything the government might prefer not to have examined closely. The UAP Disclosure Act, passed as part of the National Defense Authorization Act for fiscal year 2024, following years of bipartisan pressure in Congress, was specifically designed to address this tension. It compels federal agencies to release historical UAP records, grants the government explicit rights over any non-human technology found, and provides whistleblower protections for individuals with knowledge of classified programs related to UAP. The legislation represents a formal congressional judgment that the previous approach of leaving disclosure entirely to executive branch discretion was inadequate. Whether the protections it provides will be sufficient to surface the most sensitive material, if such material exists, remains to be seen. Senator Kirsten Gillibrand of New York, who was among the most persistent advocates in Congress for the establishment of AARO and for mandatory UAP reporting requirements, has been watching the pursue process closely. Her office and others on the relevant oversight committees have been pushing for the release not just of historical documents, but of contemporary sensor data with the resolution needed for serious scientific analysis. Representative Tim Burchett of Tennessee has been among the most vocal in expressing skepticism about whether the government is releasing everything it has, or whether the most sensitive material is being filtered out before it reaches the public. These are questions that cannot currently be answered definitively from outside the classification system. What can be said with confidence is that the institutional momentum behind UAP transparency is now considerably stronger than it was at any previous point in history. The combination of a presidential directive, interagency coordination at the level pursue represents, formal legislation mandating disclosure, sustained congressional pressure, and genuine scientific engagement from credible researchers represents a convergence of factors that did not exist 5 years ago, and that makes it substantially harder for the classification system to absorb and suppress this material the way it absorbed and suppressed previous efforts. The one thing this story does not have, and may not have for some time, is a resolution. The files released on May 8th have not answered the central question. They have not confirmed that something non-human is operating in the Earth's atmosphere and near its moon. They have not confirmed that everything unusual ever observed by military personnel has a mundane explanation. What they have done is make the raw material for working toward those answers publicly available for the first time, in a form that allows researchers with the appropriate expertise to examine it systematically and to share their findings through normal scientific channels. That is a different kind of progress than a dramatic revelation would be. It is slower, more methodical, and less satisfying in the immediate term. but it is the kind of progress that, if pursued rigorously and honestly, has the best chance of eventually producing something we can trust. The 41 minutes of video in this initial release, the 120 documents, the 14 images, the diplomatic cables, the FBI case files, the NASA transcripts, all of it together represents a small fraction of what the government has collected over 7 decades of serious, if often secretive, engagement with this question. The decision to begin releasing that material is, regardless of what it ultimately contains, a significant historical moment. It acknowledges, officially and at the highest levels of the American government, that something worth taking seriously has been observed. That acknowledgement alone changes the landscape within which scientists, researchers, and the public approach this subject. We are at the beginning of a process, not the end of one. The files are open, the questions are larger than the answers. And the next tranches of documents, already in review somewhere in the layered bureaucracy of the American classification system, may add pieces to a puzzle that has been accumulating evidence for longer than most living people have been alive. There is something worth sitting with before we go deeper. If you've been following this story across multiple sources in the days since the release, you will have encountered a very wide range of interpretations, some confident that these files prove everything skeptics have denied, others equally confident that the release is a masterclass in releasing a great deal while saying very little. Neither position is fully satisfying, and the discomfort that creates is actually the appropriate intellectual response to the current state of the evidence. The material in these files is genuinely ambiguous in ways that resist easy resolution. It asks something of the reader that most news cycles are not designed to accommodate, which is patience, rigor, and the willingness to hold competing possibilities in mind simultaneously while waiting for better data. As always on this channel, I want to be clear that what I've laid out here represents our best reading of the available evidence at this moment. I'd encourage you to go to the original Pursue website to read the AARO reports, to look at what the scientists studying this subject most carefully are saying in their own words. Cross-reference what you find with what we've described here, and make your own assessment. This subject is too important, and the stakes of getting it wrong in either direction are too high for any single source to be treated as definitive. What comes next in this story? The additional tranches of documents already promised by the Department of War, the ongoing scientific analysis being conducted by Loeb's Galileo project and others, the congressional pressure for more complete disclosure, the continued operation of AARO's sensor systems in the field, all of that will determine whether this historic moment of openness becomes the foundation for genuine answers, or another chapter in a long story of questions that outlast the documents meant to resolve them. One of the aspects of the Pursue release that has attracted sustained attention from researchers who have spent years working through this material is the sheer variety of the human experiences it documents. This is not a collection of radar blips and sensor logs alone, although there are plenty of those. It is, in a meaningful sense, a record of what some of the most carefully trained observers in the world have seen, heard, and felt when they encountered something they could not explain. The cumulative weight of that human testimony, spanning 8 decades, 6 continents, and every tier of military and civilian authority, is one of the things that makes dismissing this subject entirely so intellectually difficult. Consider what the Gemini 7 transcripts reveal. In December of 1965, roughly 4.5 hours into the mission that would keep Frank Borman and Jim Lovell in space for nearly 14 days, Borman made a transmission to Houston that used a word no civilian passenger would use but that every military aviator understands immediately. He reported a bogey at 10 o'clock high. Houston asked him to repeat. Borman confirmed it was, in his words, an actual sighting, and described what he saw as looking like hundreds of little particles going by to the left, out about 3 or 4 miles. Lovell, looking out the opposite window, reported that he could see the mission's rocket booster in the sunlight, surrounded by what he called trillions of particles. Both men, who both passed away in recent years, maintained for the rest of their lives that they had been looking at debris, at fragments and ice crystals associated with their own spacecraft or its booster. Borman's use of the word bogey, which carries a specific aeronautical meaning of an unidentified contact, has been discussed in UAP research circles for 6 decades. The audio of that exchange, now publicly available through the Pursue portal, carries something that a transcript cannot fully convey. There is the sound of professional composure in Borman's voice, the measured precision of someone trained to report clearly under pressure, and somewhere in that precision there is also the unmistakable quality of genuine uncertainty, He's reporting what he sees, faithfully and carefully. He's also not quite sure what it is. That same quality, the quality of a trained observer, encountering something unexpected and working to describe it accurately, without overclaiming, runs through many of the most compelling documents in this release. The Apollo 17 transcripts bear it too. When Mission Commander Eugene Cernan described the flashing object visible from the spacecraft several miles away, he was careful and specific. He noted that the flashes were apparently rotating in a very rhythmic fashion, that they came around almost on time, as he put it. He distinguished the object clearly from the nearby particles that were drifting around the capsule, noting that it was obviously not one of those because it was way out in the distance. This is the language of precise observation, not speculation. Cernan was a naval aviator, a test pilot, and one of only 12 people in history to have walked on the moon. When he reported something at distance that was flashing rhythmically, he was reporting an observation, not a feeling. What those observations actually represent is still unknown. The most straightforward natural explanations, ice crystal reflections, spacecraft debris tumbling in the sunlight, atmospheric particles illuminated by the sun from unexpected angles, cannot be definitively ruled out for any of these events. But they also cannot be confirmed without the original footage and full engineering analysis of the spacecraft's condition at that specific moment in the mission. AARO has now opened a formal investigation into the Apollo 17 photograph. The government has stated that it has obtained the original film from that mission, and that the results of the full NASA and Department of War analysis will be released when completed. That commitment to formal scientific analysis of 53-year-old mission materials is itself a measure of how much the institutional posture on this subject has changed. The Apollo 12 imagery adds another layer. A photograph taken at the landing site in 1969, reproduced in the Pursuit archive, shows the lunar surface with an area of interest slightly above the horizon, in which what appear to be unidentified phenomena are visible. During that same mission, astronaut Alan Bean reported flashes of light that he described as sailing off into space. Bean's description is interesting partly because of its specificity, and partly because the known phenomenon of cosmic ray flashes, which Buzz Aldrin described in connection with the interior cabin lights observed during Apollo 11, involves flashes perceived inside the closed eye, not objects sailing visibly away through the window. Bean was reporting an external observation, not a neurological one. The distinction matters even if the ultimate explanation proves to be mundane. What these mission transcripts collectively suggest is that encounters with unusual phenomena in the space environment were not rare aberrations during the Apollo era, but something closer to a recurring feature of deep space travel in that period. The available instrumentation of the time was not equipped to capture high-quality data on such encounters. Cameras were film-based and limited by exposure settings optimized for specific planned photographic tasks. Mission Control, aware of the need to keep crews focused on mission-critical objectives, did not press for extended discussions of unusual observations during the missions themselves. The debrief transcripts represent the first opportunity for detailed discussion of what crew members had experienced, and those debriefs, until last week, sat in classified archives that the general public had no right to access. The release of this material, even in its current incomplete form, represents an act of institutional accountability that is worth recognizing. It is the government saying, explicitly, that these events happened, that trained observers reported them through official channels, and that no satisfactory explanation was ever arrived at. The statement in the Pursuit archive's accompanying notes for the Apollo 17 photograph, that preliminary analysis indicates the feature is potentially the result of a physical object in the scene, and that there is no consensus about the nature of the anomaly, is not the language of bureaucratic deflection. It is the language of honest uncertainty. And honest uncertainty, applied to evidence that has been sitting in a vault for half a century, is the appropriate starting point for scientific inquiry. The contemporary incident reports in the release bring their own distinct texture. The Middle Eastern reports in particular carry the weight of operational context that the historical Apollo materials lack. These are encounters that took place in active combat zones, in airspace where multiple militaries and armed groups were operating simultaneously, using equipment designed for targeting and reconnaissance rather than scientific measurement. The report of a mysterious craft crossing surveillance screens at high speed during an American strike operation in Iraq in 2024 is striking not only for what it describes, but for where it occurred. A strike operation requires intense sensor focus. Every element of the target environment is being monitored with some of the most sophisticated equipment in the American military's inventory. The fact that something crossed that sensor picture without identification at a speed that made it notable enough to file a formal report suggests it was not simply a missed drone or an optical artifact. The Syria reports from the same period describe multiple glares or light sources of unknown origin, a categorization that is genuinely ambiguous in the context of active airspace over a conflict zone. Syria during that period saw the operation of aircraft and drones from the American coalition, the Russian military, the Syrian Arab Army, various Iranian-backed militias, and Turkish forces, in addition to whatever commercial and civilian activity was still occurring. Identifying every light source in that environment at night through an infrared sensor at altitude against the background of an active and complex battle space is not a trivial task. Unknown origin in that context means specifically that the reporting analyst could not attribute the observation to any of the known actors in the area. That is not nothing. The question of adversarial drone activity deserves more detailed attention than it typically receives in popular coverage of the UAP subject, because it represents the most immediately actionable concern in the current files. Former Navy fighter pilot Ryan Graves, who founded the organization Americans for Safe Aerospace and has testified before Congress about his own UAP encounters during training flights, has been explicit about this framing. The mystery drone incidents over New Jersey in late 2024, which saw unexplained aerial objects flying over military installations and sensitive facilities for weeks without identification, demonstrated something that Graves described as a national security gap. Not necessarily because foreign adversaries were responsible, though that possibility could not be ruled out, but because the American military and law enforcement apparatus simply could not determine what the objects were, where they came from, or who was operating them. The inability to answer basic questions about objects in your own airspace is, in itself, a significant vulnerability regardless of what those objects turn out to be. AARO has consistently acknowledged this dimension of the problem. The office's mandate explicitly includes assessing UAP activity near military installations and sensitive facilities. In the FY 2024 Consolidated Annual Report, AARO documented 18 incidents of drone encounters near nuclear infrastructure, weapons facilities, and launch sites. For none of those encounters was AARO able to confirm adversarial attribution. The office was equally unable to rule it out. That ambiguity, maintained across hundreds of incidents over several years, is what drives the congressional pressure for both better sensor coverage and more aggressive declassification. You cannot make policy decisions about adversarial drone activity if you cannot determine whether the drones are adversarial. The Gremlin sensor system that AARO has been developing is intended in part to close this gap. The Georgia Tech Research Institute developed the Gremlin architecture, which integrates several simultaneous sensing modalities, including optical, infrared, radar, and audio, designed to work together to characterize any aerial object that passes through the sensor field. The critical innovation is triangulation. By operating multiple sensor units separated by enough physical distance to allow parallax calculations, the system can determine the actual distance, and therefore the actual size and velocity of an observed object, rather than relying on the angular estimates that single sensor encounters produce. Gremlin successfully completed a test event in March of 2024. Its 90-day pattern of life deployment at a site of national security significance, announced in that year's AARO annual report, would represent the first time a purpose-built multimodal sensor system was systematically applied to the UAP problem over a sustained operational period. The data from that deployment, if and when it reaches public release, will be qualitatively different from anything in the current Pursue archive. The Galileo project's approach to this same problem is worth examining in some detail because it represents the civilian scientific community's independent effort to generate the kind of data that would actually resolve the UAP question, rather than simply document it. Avi Loeb and his team have built observatories that use the principle of triangulation, observing the same airspace from multiple units separated by approximately 10 kilometers to determine the actual distance, velocity, and acceleration of any detected object. The system uses artificial intelligence to classify objects in real time, sorting them into familiar categories including aircraft, drones, helicopters, balloons, satellites, and birds, based on their optical signatures and movement patterns. Anything that does not fit into those familiar categories is flagged for detailed review. Loeb has been characteristically direct about the goal of this work. If even one object is detected whose measured velocity and acceleration lie outside the performance envelope of any known human-made or natural aerial object, the scientific case for something genuinely anomalous becomes defensible in a way that eyewitness testimony and grainy infrared footage cannot support. The threshold Loeb sets for himself is exactly the threshold that the current government evidence fails to meet, not because the government has been hiding the relevant data, but because the sensors that captured most of the existing footage were not designed to provide the measurements that would make such a determination possible. The contrast between the government's declassified evidence and the kind of evidence the scientific community actually needs is one of the central tensions in the current moment. What the Pursuit archive contains is genuine, in the sense that these are real reports from real people operating real equipment. What it largely lacks is the calibrated, multi-sensor, triangulated, high-resolution data that would allow a physicist to say with confidence that a given observed object was or was not performing beyond the limits of known physics. That gap between what exists and what is needed is not a criticism of the people who filed these reports. It is a description of the state of the field. There is, however, a category of evidence within the existing material that is somewhat more tractable than grainy infrared video. The cases involving multiple independent observers, multiple sensor types, and corroborating radar data. The incidents that generated the original 2017 New York Times report, the encounters that Navy pilots in the Pacific reported across multiple deployments, beginning around 2014, involved not only visual sightings but radar contacts confirmed on ship-based systems, airborne sensors, and sometimes electro-optical tracking equipment simultaneously. When multiple independent sensor systems register the same contact, and when those contacts are consistent with each other in terms of position, speed, and behavior, the probability that all of them are simultaneously producing the same artifact or misidentification drops substantially. The Tic Tac incident, as the most discussed of those encounters came to be known informally, involved visual observations by Navy pilots flying combat air patrols off the aircraft carrier USS Nimitz in 2004, supported by shipboard radar that tracked the object over an extended period before the pilots were directed toward it. The pilots described an object approximately the size of a commercial airliner, elongated, white, no obvious propulsion, no flight surfaces, no exhaust, hovering at altitude before accelerating away at a speed and in a direction that the pilots stated was unlike anything they had seen. The infrared video released in 2017 shows a brief portion of one of those encounters, captured by the targeting pod of one of the pursuing aircraft. The video itself is inconclusive as a standalone piece of evidence. The broader body of evidence associated with that encounter, including radar records and the debriefings of multiple crew members, is more substantive. AARO has reviewed the Tic Tac incident as part of its historical record work. Its assessment, like its assessment of most unresolved cases, is that the available evidence is insufficient to reach a definitive conclusion about what the object was. That is not the same as saying there is no case here. It is saying that the evidence, as it exists, does not support a specific attribution. The difference between those two positions is important and is frequently collapsed in popular discussion of these cases. There is a dimension of the current release that has received relatively little attention in the first wave of coverage, but which carries significant long-term implications for how this story develops. The Pursuit archive establishes a public, searchable, permanently accessible record of what the government has collected and how it has assessed it. That record can now be cross-referenced against other databases, including the growing archive of civilian UAP reports, the catalogues maintained by organizations like the National Aviation Reporting Center on anomalous phenomena, and the observational data being generated by projects like the Galileo Project's network of observatories. This cross-referencing is something that was not possible as long as the government material remained classified. When researchers can compare the geographic and temporal distribution of government-documented incidents against independently collected civilian data from the same time periods and locations, patterns that might not be visible in either dataset alone can potentially emerge. When AARO notes that nearly half of the UAP incidents reported between May 2023 and June 2024 occurred near military installations or sensors, that observation becomes more analytically powerful when it can be compared against civilian reports from the same areas at the same times. Are civilians in those areas reporting similar observations? If so, that strengthens the case that something was actually there to be observed, rather than that the military sensor environment was generating its own artifacts. If civilian reports from those areas are sparse or absent, that tells a different story about whether what was detected was genuinely present in the physical environment or specific to the military sensor systems. This is the kind of systematic cross-dataset analysis that the scientific community is now positioned to do in a way that was not possible before May 8th. The computational tools, the statistical methods, and the machine learning architectures needed for this kind of work exist and are being actively developed by multiple research groups. The raw material is now, at least in its first tranche, publicly accessible. What was missing until recently was the combination of institutional legitimacy and data availability that makes such work both scientifically credible and practically possible. The NASA Independent Study Team report, released in September of 2023, was an important precursor to this moment. The team, which included scientists from academia, industry, and the federal government, was chaired by the president of the Simons Foundation and included some of the most respected researchers in relevant disciplines. Its mandate was specifically not to determine whether UAPs are extraterrestrial in origin, but to identify the best data streams available to resolve UAP cases and to recommend how NASA could contribute to the investigation. The team's conclusion, broadly stated, was that the current data is inadequate for scientific analysis and that a systematic, instrumented approach to data collection is necessary before meaningful conclusions can be drawn. NASA subsequently established a dedicated UAP research director position, acknowledging that this is a legitimate scientific question deserving of the agency's serious attention. The connection between NASA's institutional posture and the current Pursue release is more than symbolic. NASA Administrator Jared Isaacman welcomed the Pursue initiative explicitly, describing it as consistent with NASA's mission to follow the data and share findings openly. For an agency whose credibility rests entirely on its commitment to evidence-based inquiry, that endorsement carries weight. It signals that the scientific establishment, as represented by one of its most respected institutions, is willing to engage with this material rather than maintain the polite distance that characterized the previous generation of official scientific attitudes. The question of what future Pursue tranches might contain is one that researchers, journalists, and members of the public who have been following this story are asking urgently. The government's commitment is to rolling releases every few weeks as material is reviewed and cleared. The 46 videos specifically requested by Congresswoman Anna Paulina Luna, which AARO Director John Koslowski has acknowledged exist, but which did not appear in the first release, are among the most anticipated. Loeb's prediction that the higher quality data will take longer to work through the classification review because it involves sensor capabilities that are themselves classified seems likely to hold. The most useful scientific data is probably also the most sensitive from a national security standpoint, because it was captured by the most advanced systems. Releasing that data means revealing something about what those systems can do. This creates what is perhaps the most fundamental tension in the entire Pursue project. The purpose of classification, in the context of sensor capabilities, is to prevent adversaries from knowing exactly how good your detection systems are, and therefore from knowing exactly how to evade them. If American surveillance satellites can image objects at a resolution that would allow definitive identification of a drone's country of manufacture from orbital altitude, releasing footage that demonstrates that capability tells adversaries precisely what they need to know to defeat that surveillance. The argument for keeping the most revealing imagery classified is not irrational, even in the context of a genuine commitment to transparency. The argument against it is that the public cannot meaningfully evaluate what it is not allowed to see, and that a transparency effort that withholds the most significant evidence is performing transparency rather than practicing it. The congressional oversight community, led in this area by senators like Kirsten Gillibrand and members like Anna Paulina Luna, has been pressing for exactly this material and has not been fully satisfied by what the executive branch has provided in previous classified briefings. Whether the Pursue process will eventually bridge that gap, or whether the most compelling classified evidence will remain classified regardless of the Transparency Initiative's public commitments, will be one of the defining questions of this ongoing story. There is a philosophical dimension to all of this that deserves direct acknowledgement, even in a documentary committed to staying grounded in verified evidence and scientific rigor. The question of whether humanity is alone in the universe is not merely a scientific question. It is one of the deepest questions available to a thinking being. If the answer is that we are not alone, that other civilizations exist or have existed, that their presence in some form can be detected in the physical evidence available to us, then virtually every framework through which human beings understand their place in the cosmos is affected, not shattered necessarily, but affected, expanded, complicated in ways that would take generations to fully absorb. The history of science is full of moments when the discovery of something genuinely new required not just an update to the existing framework, but a rethinking of the assumptions on which the framework rested. Copernicus displaced Earth from the centre of the universe. Darwin connected human beings to the broader web of life through common descent. Hubble demonstrated that the universe is vastly larger than anyone had previously imagined, and that it is expanding. Each of those discoveries was initially resisted, partly for scientific reasons and partly because the implications were uncomfortable. The resistance was eventually overcome, not by assertion, not by politics, but by the accumulation of evidence that could not be explained any other way. The UAP question is not yet at that point. The evidence in the Pursuit archive is suggestive but not conclusive. The scientific infrastructure for generating conclusive evidence is being built but is not yet operational at the scale the problem demands. The institutional barriers to the most sensitive data reaching public and scientific review have not yet been fully overcome, but the direction of travel is clear. More data is being collected, better instruments are being deployed, more scientists are directing their attention and their analytical tools toward this question, and the government, for the first time in the modern history of this subject, has made a formal, interagency, publicly accountable commitment to releasing what it has collected. There are still significant reasons for scientific caution. Neil deGrasse Tyson, an astrophysicist at the American Museum of Natural History and one of the most widely read science communicators of his generation, has described the gap between what people perceive in UAP encounters and what the physics requires as a product of what he calls the aliens of our ignorance, meaning that when we do not understand what we are seeing, the explanation we reach for tends to be the most dramatic one available. Most extraordinary observations, he argues, eventually turn out to have ordinary explanations that we simply had not considered. The history of astronomy is full of examples where anomalous signals that briefly suggested exotic possibilities turned out, with better data, to have mundane natural explanations. This caution is scientifically legitimate and should be held in mind when evaluating any individual case in the Pursuit archive. At the same time, Tyson's position, like that of any position based on historical precedent, carries a risk of its own. The fact that previous unexplained observations turned out to have mundane explanations is not evidence that all future unexplained observations will do the same. At some point, if civilizations exist elsewhere in the universe, and if they have developed the capability to reach or probe other stellar systems, some human observation of that activity will be genuine. The question of whether any current UAP evidence represents such an observation is one that evidence, not prior probability estimates, will eventually answer. The interstellar object story provides useful context here. When 1I/Oumuamua passed through the solar system in 2017, its anomalous properties, including its unusual shape and unexplained non-gravitational acceleration, prompted exactly the debate that UAP evidence consistently generates. A minority of scientists, led by Loeb, argued that the anomalies were worth taking seriously as potentially technological in origin. The majority favoured natural explanations. The scientific process continued. No consensus was reached before Oumuamua left the solar system beyond detection range. The question of what it was remains genuinely open in the scientific literature, even if popular coverage has largely moved on. The third interstellar object, 3I/Atlas, detected in July of 2025, is still within observation range and is generating an active research program. Its anomalies are different from Oumuamua's, but are being examined with the same scientific rigor. Loeb and his colleagues have been publishing analysis of its jet structures, its deuterium abundance, its non-gravitational acceleration patterns in refereed journals and preprint archives, subject to the normal processes of scientific review and replication. Whatever 3I/Atlas turns out to be, the process of investigating it represents science working as it should. The UAP investigation, if it develops the data quality and institutional infrastructure it currently lacks, could work the same way. This is the vision that the most scientifically engaged participants in the current UAP moment are articulating. Not the revelation of a hidden truth that the government has been concealing, though that possibility has not been definitively eliminated. Not the confirmation of a decades-long conspiracy, though the history of classification and institutional suppression in this area is real and documented. But the creation of the conditions under which the question of what these observations represent can be investigated with the same rigor, openness, and methodological discipline that science applies to any other difficult empirical question. The Pursue initiative is a beginning, not a conclusion. 161 records, however significant the moment of their release, represent a small fraction of what the government has accumulated over nearly 80 years of engagement with this subject. The website itself, with its white typewriter font on a black background and its stark presentation of documents that were classified last week, has the quality of an opening statement rather than a final report. The government has said, in effect, here is some of what we have. We will release more as we are able. We invite you to look at it and draw your own conclusions. That invitation carries a responsibility that falls on everyone who takes it up. The responsibility to look at this material carefully and honestly, without the preconception that it must confirm a preferred narrative. The responsibility to cross-check claims against the original sources, to distinguish between what a document says and what an interpretation of that document says, to hold the genuinely anomalous separate from the merely unexplained, and to maintain the distinction between interesting evidence and conclusive proof. These are the standards that serious inquiry demands, and they are exactly as applicable to UAP evidence as to any other category of scientific or historical investigation. And this is something I want to say directly because it matters to the way this channel approaches every topic we cover. The files are open, the data is available, the scientists are engaging, but none of that changes the fundamental requirement that each of us who follows this story does so with our own critical thinking intact. Read the primary documents. Look at what AARO has actually said and not said. Examine Loeb's analysis and the skeptic's analysis side by side. Notice where the evidence is strong and where it is thin. This subject deserves that care, and so do you as someone trying to understand it honestly. What does remain undeniable, after reviewing everything in this initial release and the scientific and institutional reaction to it, is that the question at the heart of this story has never been more seriously engaged at every level of the relevant institutions simultaneously. Researchers at Harvard are analysing the files within hours of their publication. AARO is formally reopening investigation of a 53-year-old NASA photograph. The Department of War has committed publicly and formally to releasing more. Congress is pushing for the highest quality data. NASA has endorsed the process and pledged to contribute to the analysis, and the public for the first time has direct access to the raw material. The 7 decades of official American engagement with this question have produced an extraordinary archive of human experience, observation, and institutional response. That archive is now, piece by piece, entering the public domain. What the people who have access to it, the scientists, the researchers, the informed and curious members of the public, make of it will shape how this story develops. The evidence will accumulate, the sensors will improve, the analysis will deepen, and at some point the accumulated weight of evidence will either support a conclusion or it will not. That is how it always works in science. The question simply has to be asked clearly enough and investigated rigorously enough and honestly enough for the answer to eventually emerge. We are closer to that moment than we have ever been. The files are open. The questions are larger than any single release can answer. The work of finding out what is actually in our skies, in our solar system, and perhaps beyond it, has barely begun. And here on Deep Space Intelligence, we will be following every development as it comes. Thank you for spending this time with me, Liam. If this episode has raised questions for you, I encourage you to explore them through the primary sources we have discussed, through the Pursue archive itself at the official government portal, through the AARO published reports, through the scientific literature coming out of the Galileo Project and other research groups working in this space. The truth in a question this large is never the exclusive property of any single source, and that includes this channel. Stay curious, stay rigorous, and we will see you in the next one. To understand why this moment is genuinely different from every previous episode of government UAP disclosure, it is worth reviewing what those previous episodes actually produced and why they fell short. The pattern is instructive precisely because it has been so consistent, and because the Pursue initiative represents a deliberate structural departure from it. Every previous declassification effort in this area, from the partial release of Project Blue Book records to the publication of the Condon reports supporting data, to the acknowledgement of AATIP in 2017, followed the same basic model. A limited set of materials would become available, either through deliberate release, through Freedom of Information Act requests, or through leaks by individuals who believed the public had a right to the information. Those materials would generate intense public interest, would be analysed by the research community to whatever extent the available data allowed, and would then be followed by a period of institutional quiet, in which no further material was forthcoming. The cycle would eventually restart when another leak, another whistleblower, or another political moment created sufficient pressure to produce another partial disclosure. What Pursue is structured to do is break that cycle by establishing a formal, ongoing, publicly committed interagency disclosure mechanism with a rolling release schedule. Whether it succeeds in that structural goal will depend on factors that cannot yet be fully evaluated. The depth of the review being conducted, the scope of what the government is actually willing to release, and whether the political will behind the initiative survives the inevitable pressures that push classification toward expansion rather than contraction. But the structure itself represents something new, and it is worth taking seriously on its own terms even before the full scope of what it will produce is known. The involvement of the FBI in this release is one of the less discussed but genuinely interesting aspects of the first tranche. The FBI's engagement with the UAP subject stretches back to the very beginning of the modern era, to the late 1940s when a combination of public sighting reports and military incidents created enough institutional pressure that the Bureau began collecting its own documentation. The case file known as 62-HQ-83894, which appears in the Pursue archive with fewer redactions than any previous public version, represents decades of FBI engagement with reports, witness interviews, and material submitted by individuals who believed they had encountered unusual phenomena. The newly declassified pages of that file, and the significance of what they add to the previously available partial versions, are still being worked through by researchers who have been following this case for years. The FBI photos in the initial release include infrared still images taken by military systems in late 2025 over the western United States. The official captions are notably precise in their uncertainty. One image is described as showing unidentified objects, plural, with no further characterization. Another carries the notation that the operator reported being unable to positively identify the UAP and that the date displayed in the image is incorrect due to the system's date and time settings not having been properly configured. That last detail, while it might seem like a minor technical footnote, is actually a meaningful piece of information. It tells you something about the conditions under which this particular observation was made and documented, and it is the kind of granular, unglamorous detail that makes the Pursue archive feel genuinely different from a curated public relations release. These are raw files, released with their imperfections intact, and that rawness is itself a form of credibility. The State Department material in the archive deserves considerably more analytical attention than it has received in the first days of coverage. Diplomatic cables are formal government communications subject to specific protocols for their creation, transmission, classification, and retention. When an American ambassador or a senior diplomatic officer in a foreign capital decides that an observation reported to them merits formal communication to Washington through secure channels, that decision reflects a judgment that the information is significant enough to take up bandwidth in a communication system designed for matters of genuine importance to national interests. The cables in the Pursue archive, spanning 40 years and originating from 5 different countries, represent a pattern of American diplomatic attention to UAP-type incidents that extends far beyond the domestic military context. The cable from Tajikistan in 1994, reporting a commercial airline crew's encounter with a strange object at 41,000 feet, was filed while that country was still in the immediate aftermath of the Soviet Union's dissolution and was navigating a period of extreme political and institutional instability. An American diplomatic presence in Dushanbe at that moment was focused on matters of enormous geopolitical consequence. The decision to include a UAP report in formal cable traffic to Washington, under those circumstances, reflects a judgment that the information was worth the bandwidth. What happened to that cable in Washington, whether it was analysed, whether it was correlated against other reports from the post-Soviet space in that period, whether it contributed to any broader assessment, is not visible from the released document alone. But the document's presence in the archive tells you that it was retained and considered relevant enough to preserve across 3 decades of classification review. The geographic breadth of the State Department cables, touching Papua New Guinea, Kazakhstan, Turkmenistan, Georgia, Mexico, and Tajikistan, suggests something about the global distribution of incidents that get formally documented through American diplomatic channels, as opposed to those that are handled purely through military or intelligence reporting. The incidents that appear in diplomatic cables are those encountered by, or reported to, civilian observers, commercial aviation, local officials, and American Foreign Service personnel in contexts that are not military operations. They represent a different slice of the phenomenon than the military incident reports, and together they describe a global pattern that no single country analysis can fully capture. The FBI file from 1966, which contains composite sketches attached to a report of small beings emerging from a saucer-shaped craft, is among the most arresting documents in the archive for the obvious reason that if taken entirely at face value, it would represent extraordinary evidence of non-human intelligence. It is also, for equally obvious reasons, the document most in need of careful, skeptical analysis. Mid-1960s America was in the midst of a cultural moment of intense UFO fascination, driven partly by genuine unexplained incidents and partly by a surge in popular culture representations of alien visitors. The same cultural moment produced a significant volume of hoaxes, misidentifications, and sincere but misleading reports from individuals who experienced unusual events and interpreted them through the frames available to them. The presence of this document in an FBI case file tells you that someone in the Bureau considered the report worth documenting and retaining. It does not, by itself, tell you anything about whether the reported events occurred as described. This is the essential epistemological challenge with historical documents of this kind, and it is one that researchers working through the Pursue archive will need to apply consistently and without exception. The existence of a document is not evidence of the events the document describes. It is evidence that the events were reported. The quality of that documentation, the consistency of accounts, the presence or absence of corroborating physical evidence, the expertise and credibility of the reporting observers, the conditions under which the report was made, all of these factors affect how much weight any individual document can carry in a broader assessment. Applying those criteria consistently, rather than selectively endorsing documents that support a preferred conclusion while dismissing those that complicate it, is the minimum standard of intellectual honesty that this subject demands. The science of what would constitute definitive proof of non-human technology is worth making explicit, because it is a higher and more demanding standard than what appears in any document currently available to the public. Proof would require an observed object whose measured kinematic properties, its verified distance, velocity, and acceleration over a known time interval, place it outside the performance envelope of every known aerial object, natural or human-made. It would require that those measurements be made by calibrated instruments whose accuracy and precision are independently verified. It would require that all conventional explanations, including atmospheric effects, sensor artifacts, coordinate transformation errors, and software processing anomalies, be rigorously excluded. And it would require independent replication, meaning that separate measurement systems at separate locations confirm the same kinematic properties. No evidence currently in the public domain meets all of those criteria simultaneously. Some evidence comes closer than others. The multi-sensor Navy encounters from 2004 through 2014, involving simultaneous radar and visual contacts with consistent apparent positions and velocities, approach several of those criteria. But the sensor calibration data and coordinate transformation logs that would be needed to confirm the kinematic analysis are not part of what has been released. The AARO assessment of those encounters, despite having access to considerably more of the underlying data than the public does, still concludes that the evidence is insufficient for definitive attribution. This is not a counsel of despair. It is a description of what the problem requires and of how far the available evidence currently falls short of what would be needed to answer it definitively. The distance between where we are and where we need to be is not so large that it cannot be covered with the right instrumentation deployed in the right way over a sufficient period of time. the Galileo project's observatory network, the Gremlin sensor system, the potential release of higher quality classified data through Pursue, the growing integration of machine learning analysis into the assessment of large sensor datasets, all of these represent paths toward closing that distance. None of them will produce instant answers, but they represent genuine scientific progress toward a question that has been inadequately equipped for rigorous investigation since it first became a matter of serious government attention in 1947. The role of the scientific community in this moment is worth reflecting on carefully, because the historical relationship between mainstream science and the UAP subject has been one of the more significant barriers to progress. The stigma that attached to serious academic engagement with this question over the past 7 decades was real and had real consequences. Researchers who published work on UAP topics risked their reputations and their funding. Graduate students were informally discouraged from choosing research directions that touched on the subject. Journal editors reflexively declined submissions on UAP-related topics without substantive peer review. The result was a systematic exclusion of the most capable analytical minds from a question that arguably deserved their attention more than it deserved the attention it actually received, which was a mixture of popular fascination and marginal research conducted largely outside the institutional structures that give scientific work its credibility and reproducibility. The shift in that dynamic since 2017 has been gradual but cumulative. The publication of peer-reviewed work on UAP physics, atmospheric optics, sensor artifact analysis, and statistical modeling of incident reports in mainstream journals has become more common. The Galileo project has published its methodology and preliminary findings in peer-reviewed literature. AARO has explicitly partnered with academic institutions and sought to apply standard scientific methodology to its case analysis. The National Academies of Sciences have not yet taken a formal position on the UAP question as a scientific research priority, but the institutional barriers to such engagement have lowered significantly. When NASA establishes a dedicated UAP research director position and its administrator publicly endorses the Pursue initiative, the signal to the broader scientific community is unmistakable. The economic dimension of serious UAP investigation is also worth noting, because it is one of the practical constraints on how quickly the scientific infrastructure can be built. The Galileo project operates on a budget that Loeb himself has described as 1,000,000 times smaller than the annual defense budget. The research programs most capable of generating the kind of data that would actually resolve the UAP question require significant investment in sensor systems, computational infrastructure, data storage, and scientific personnel. That investment has historically been nearly impossible to justify through conventional academic funding channels because the subject sat outside the boundary of what could be proposed without career risk. As that barrier erodes, the funding landscape may shift. Several philanthropists with scientific interests have already contributed to the Galileo project. Whether the scale of funding available through private channels will be sufficient to build the observatory network and analytical infrastructure the problem requires remains to be seen. The political economy of the Pursue initiative itself is worth examining with some care. The timing of the release, coming in the early months of an administration that made specific promises about UAP disclosure, creates a context in which the political incentives and the scientific requirements may not always point in the same direction. An administration that promised transparency benefits from being seen to deliver it, even if the material delivered is less substantive than the public hoped. A genuine scientific investigation requires that the quality of the released data be sufficient to support meaningful analysis, not merely that the act of release be visible and dramatic. Whether Pursue will prioritize substance over appearance, and whether the reviewing and approving layers of the classification system will cooperate with substantive disclosure rather than technically compliant but scientifically inadequate releases, are questions that only the subsequent tranches will answer. The connection between UAP disclosure and the broader question of government transparency deserves acknowledgement because it is not incidental. The public pressure that built behind UAP disclosure over the past decade was driven in part by a more general erosion of trust in government institutions. People who believed the government had been lying about UFOs for decades were drawing on a wider history of documented cases in which official statements turned out to be incomplete or misleading. The existence of AATIP, which operated for years without public acknowledgement, fed that distrust directly. The Kona Blue proposal, revealed in the AARO Historical Record Report, demonstrated that at least some people within the government believed that secret reverse engineering programs either existed or should exist. The gap between what officials said publicly and what the historical record showed they knew privately has been, in this area as in others, a source of legitimate grievance. The Pursue initiative in this context is also an effort to rebuild trust, to demonstrate that the government can and will make available information it has previously withheld. Whether the information being released is adequate to that purpose, whether it addresses the specific concerns that drove distrust rather than managing them without resolving them, is something the public will assess as the releases continue and as the gap between what has been released and what researchers believe exists becomes clearer or murkier. There are people working inside the national security apparatus right now who have access to the classified sensor data that the public does not yet have access to, who have read the intelligence assessments that have not yet been cleared for release, who know more about what the most advanced American surveillance systems have detected than will be publicly available for years. Some of those people believe, based on what they have seen, that the unresolved cases represent something genuinely unprecedented. Others believe, with equal conviction and access to the same material, that the unresolved cases will eventually yield to conventional explanations when better data becomes available. The existence of both camps within the same classification infrastructure, among people with comparable access and expertise, is perhaps the most honest summary of where the institutional knowledge actually stands. Neither camp is making things up, neither is demonstrably right. The question is genuinely open in the minds of the people most qualified to assess it. That is the actual state of the science, as best as can be reconstructed from the available information. And that honest, uncomfortable, genuinely open state is what the Pursue files, for all their incompleteness, most accurately reflect. The universe is approximately 13.8 billion years old. The Milky Way galaxy contains somewhere between 100 billion and 400 billion stars. Current estimates from exoplanet surveys, particularly the data returned by the Kepler Space Telescope, and more recently the Transiting Exoplanet Survey satellite, suggest that the majority of those stars host planetary systems, and that a significant fraction of those systems include planets in the habitable zone where liquid water is possible. The James Webb Space Telescope is now capable of analysing the atmospheric compositions of planets around nearby stars, searching for chemical biosignatures that would indicate biological activity. None of those searches has yet returned a confirmed positive result, but the instrumentation is now powerful enough that if Earth-like biosignatures exist at detectable concentrations in the atmospheres of nearby exoplanets, we would be able to find them within the next decade or two. In that context, the question of whether anything non-human is observable in the near-Earth environment is not one that can be answered by dismissal. It is one that requires investigation with the best available tools. The Pursue files are not those tools. They are the accumulated record of what happened before those tools existed. But they are also the public acknowledgement that the question is legitimate, that the observations are real, and that the government's previous posture of institutional silence was inadequate to the evidence it had collected. That acknowledgement is the most important thing this initial release has produced, not the confirmation of extraterrestrial visitors, because the evidence does not support that conclusion, not the definitive explanation of every observed phenomenon, because the data does not support that conclusion either, but the formal, interagency, publicly committed recognition that something worth investigating has been observed, that the investigation deserves scientific resources and methodological rigour, and that the public has a legitimate interest in what that investigation finds. That is where we are. The archive is open, the analysis is ongoing, the sensors are being upgraded, the scientists are engaged, the questions are as large as they have ever been, and the answers, if they come, will come from evidence, from measurement, from the patient and rigorous application of the scientific method to a question that is very old and very difficult and very much worth asking. This is deep space intelligence, and we will be here for every step of it. The history of how human understanding has expanded when it was forced to confront something it did not have a ready explanation for is, in some respects, the history of science itself. Every major revision of the scientific worldview was preceded by a period of anomaly accumulation, a gathering of observations that the existing framework could not comfortably accommodate, that was followed eventually by a framework revision capable of incorporating them. The UAP evidence may represent such an accumulation, or it may represent a large collection of phenomena that will eventually yield to conventional explanations once the data quality improves. The responsible position is to treat both possibilities as genuine, to let evidence rather than expectation determine the outcome. What the Pursue archive has done, at minimum, is establish the factual baseline more clearly than it has ever been established before. The government has formally documented that its military and intelligence personnel have observed phenomena they could not identify, that those observations have been made with sophisticated instruments in multiple contexts across multiple decades, that a significant fraction of those observations have resisted explanation despite serious analytical effort, and that none of the investigations conducted to date has found evidence sufficient to conclude that the phenomena are extraterrestrial in origin, but that none has found evidence sufficient to conclusively rule that possibility out. That baseline is simultaneously less dramatic than many people hoped, and more substantive than the government's previous public posture implied. It is the honest answer to the honest question, and honest answers, even when they are incomplete and unsatisfying, are the necessary foundation of any genuine inquiry. There is a version of this story that has dominated popular culture for decades, in which the government knows the truth, has been hiding it, and the disclosure we are witnessing is the beginning of the end of that concealment. There is another version, favoured by the most committed skeptics, in which the entire phenomenon is a combination of misidentification, cultural psychology, and institutional dysfunction that has been generating more heat than light for 3/4 of a century. Both versions are too simple. The evidence does not support either of them fully, and the people who have engaged with that evidence most carefully, the scientists, the military analysts, the intelligence professionals who have reviewed the classified record, tend to arrive at positions considerably more nuanced than either. The nuanced position is harder to hold. It requires living with uncertainty, maintaining the distinction between what is known and what is merely interesting, resisting the pressure to resolve ambiguity in favour of a satisfying narrative. But it is the position that the evidence actually supports, and it is the position that any genuine investigation has to start from if it is to make progress. The world changed in a meaningful way on May 8, 2026. Not because a definitive answer was delivered, not because a smoking gun appeared, but because the formal architecture of American government oversight of this subject was reorganized around a commitment to public access rather than institutional secrecy. That reorganization creates possibilities that did not previously exist. It makes the scientific investigation of these phenomena more tractable. It creates accountability for what the government chooses to release and what it continues to withhold. It gives researchers access to primary sources they have never been able to examine directly. And it puts the question of what is in our skies, in our solar system, and perhaps beyond it, into the public domain in a form that invites rigorous, serious, methodologically sound inquiry. That is what this moment represents. Not an answer, a beginning. And here at Deep Space Intelligence, a beginning is exactly what we are here to explore. There is one more thread that runs through this entire story, and that deserves to be followed to its end, even as the larger questions remain open. It is the thread of individual human beings, the pilots and sensor operators and intelligence officers and astronauts, who encountered something they could not explain and chose to report it honestly through channels that for most of their careers carried the implicit risk of ridicule or professional consequence. Ryan Graves, who flew combat air patrols in the Pacific and encountered UAP phenomena repeatedly with his squadron, described the experience of seeing the New York Times coverage of the same events he had personally witnessed as a cry for help. He did not use that phrase lightly. He used it to describe the experience of watching something that had been real, documented and formally reported, be treated as marginal, until a newspaper made it impossible to ignore. The decision to found Americans for Safe Aerospace, to testify before Congress, to speak publicly about what he and his fellow pilots experienced, was not a decision made carelessly. It was made because the alternative, continued silence in the face of genuine observations, seemed worse. David Fravor, the Navy commander who led the intercept of the Tic Tac object in 2004, has described what he saw with the same combination of precision and honesty that characterizes the best of the astronaut transcripts. He saw what he saw. He reported it. He maintained for 2 decades that he did not know what it was, only that it did not match anything in his extensive experience of military aviation. His credibility, built over a career of distinguished service, is part of why the Tic Tac encounter became impossible for the institutional establishment to ignore when it was eventually reported. The individuals in the FBI reports, the intelligence officers who filed accounts of super-hot orbs moving faster than pursuit helicopters, the commercial pilots who reported encounters through diplomatic channels in countries far from the American airspace where most UAP coverage is concentrated, all of them made a decision to put their observations into the official record in contexts where that decision carried personal and professional costs. That decision deserves respect, and the records they created deserve the serious analytical attention they have been denied for too long. The opening of the Pursue archive is, among other things, an act of institutional recognition that those individuals were telling the truth about what they observed, even if what they observed has not yet been explained. That recognition is overdue, and the scientific work that now becomes possible, because their observations have been formally acknowledged and made publicly accessible, represents a delayed but genuine honouring of the commitment those observers made when they chose to file a report rather than remain silent. The universe continues its ancient business regardless of what we make of any of this. Stars are being born in molecular clouds across the Milky Way at this moment. Planetary systems are forming around young stars in the Orion Nebula. Somewhere in the darkness between the stars, objects we have not yet catalogued are moving on trajectories that may or may not bring them through the inner solar system within the lifetimes of people alive today. The questions this moment raises about what is observable in the near-Earth environment, about what that evidence actually represents, about what it would mean for our understanding of our place in the cosmos, if some of it turns out to be non-human in origin, are questions that belong to everyone who has ever looked up at the night sky and wondered whether we are the only ones here. We are not yet in a position to answer those questions, but we are, for the first time in the modern history of this inquiry, in a position to investigate them with the seriousness and the resources and the openness that they have always deserved. The archive is open, the scientists are working, the sensors are being deployed, and the question, the oldest and most fundamental one our species has ever asked about its place in the universe, is being pursued with the rigour and the honesty that it demands. That is the story that begins with the files released on May 8th, 2026. And on Deep Space Intelligence, it is a story we will continue to follow with exactly the care and the intellectual honesty that you, our audience, have always deserved from us.